Okay, this is lesson 9. We're talking about prime numbers today. So we're going to go on to our first objective, which is to define prime and composite numbers. Okay, two different types of numbers. First of all, prime numbers. A prime number is a counting number greater than 1 whose only factors are 1 and itself. Okay, so prime number is something greater than 1 whose only factors are 1 and itself. So for example, the number 5. Okay? 5 is a prime number because the only way I can multiply numbers together to get 5 is 1 times 5. Okay? It's the only way I can multiply to get 5. Another way to think of this is, imagine you want to make a rectangle with 5 blocks. Okay? Well, the only way I can make a rectangle with 5 blocks is to draw it in a 1 by 5 form. Okay, like this. Or I could turn it around and go with a 5 by 1, so it's like rotated a little bit. But there's no other way I can make a rectangle with 5 blocks. Okay, if I try to arrange it so that there's 2 blocks on top and 3 on bottom, that's not a rectangle. Or if I went with 1 block on top and 4 on bottom, that's not a rectangle. Okay, so the only way that I can make a rectangle with 5 blocks is a 1 by 5. So that's an example of a prime number. It's only got 2 factors, 1 in itself. Okay, a composite number, on the other hand, is a counting number with more than 2 factors. Okay, so there's more than one way I can multiply 2 numbers together to get it. So for example, a composite number would be 6. Okay, well, how can I multiply 2 numbers together to get 6? I can take 1 times 6, and I could also take 2 times 3. So factors of 6 are 1, 6, 2, and 3. Alright, let's use the rectangle method again. How can I arrange 6 blocks and still make a rectangle? Well, I can do a 1 by 6 setup. I could also do a 2 by 3 setup where I go 2, 2, and 2. Okay, there's 6 blocks there and it still makes a rectangle. I could do a 3 by 2 setup like this. Okay, and make a rectangle still. So that's what a composite number is. A composite number is something that has more than 2 factors. Okay, so let's write the first 10 prime numbers. Okay, because it's important to know. Again, 1 is not a prime number. So first 10 prime numbers. We'll start with 2. The only way I can multiply numbers together to get 2 are 1 times 2. Then 3. 1 times 3. And then we skip 4 because we could do 2 times 2 to get 4. Go to 5. Next one is 7. And the next one is 11. And then 13. And then 17. And then 19. And then 23. And then 29. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the first 10 prime numbers, where the only factors of those are 1 in itself. Okay? And then, let's name the first 10 composite numbers. First 10 composite numbers are 4, then 6, then 8, and then 10, then 9. Sorry, let's erase that. 9 is a composite number because I could take 1 times 9 or 3 times 3. And then 10, and then 12, and then 14, and then 15, and then 16, and then 18. It's the first 10 composite numbers. Okay, so again, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so now you know the difference between prime and composite numbers, so let's go on to the next slide. Alright, next up is objective 2. It's know and use divisibility tests for the numbers 2, 3, 4, 5, 6, 9, and 10. Okay, a divisibility test is just something that we can use to tell if a number is divisible by something else. Okay, so we're going to make a table, and we're going to have the number that we're testing, okay, and then we're going to have the rule right here, and then we're going to use this example. So here we go. A number is divisible by 2 if it is even. Okay? So if I look at the number 3420, okay? When I want to know if a number is even or not, I look at the very last number. So I'm looking at the 0. And even numbers end in 0, 2, 4, 6, or 8. Okay? So even numbers are numbers that end in 0, 2, 4, 6, or 8. Well, 3,420 ends in 0, so it is even. That means it is divisible by 2. So yes, it's divisible by 2. Okay? Here's the rule for 3. The rule for 3 is if the sum of its digits is divisible by 3. Okay? So sum means to add, and digits mean all the numbers that are in the number. So we're going to add 3 and 4 and 2 and 0 together and see what we get. Okay, so 3 plus 4 plus 2 plus 0. Well, 3 plus 4 is 7, plus 2 is 9, plus 0 is 9. Okay, so I got 9. Is 9 divisible by 3? Well, 9 divided by 3 is 3, so it's yes. Okay. Whoops, not 8. Yes. Okay, and again, when we do that, we're adding up all these digits in the number, and then seeing what we get, and seeing if this is divisible by 3. Next one, the rule for 4. A number is divisible by 4 if its last two digits are divisible by 4. Okay, so when I look at 3,420, I'm looking at the last two digits. I'm telling, are those divisible by 4? Well, 20 divided by 4 is 5, so that also works. That is yes. Okay, we'll keep moving on. 5 is easy. A number is divisible by 5 if it ends in 5 or 0. So again, we're looking at the last number, 3,420. Looking at the last number, it is 0, so it is divisible by 5. Number is divisible by 6 if it is divisible by 2 and 3. So if I look back up at my chart up here, it was divisible by 2 and it was divisible by 3. So yes, it is divisible by 6. Okay, we'll keep going here. I'll actually slide this up. I'll just show you the last two here. Okay. A number is divisible by 9 if the sum of its digits is divisible by 9. So again, just like we did up here, just like we did up here, we're going to add all the digits together and tell if that number is divisible by 9. So I'm going to take 3 plus 4 plus 2 plus 0, and that equals 9. Well, is 9 divisible by 9? 9 divided by 9 is 1. So the answer again is yes. And a number is divisible by 10 if it ends in 0. So again, I'm looking at just the last digit here. It is 0, so the answer is yes. Okay. Now these rules are really going to help us out because when we talk about prime numbers, we can use these to tell if a number is prime or not. Okay. Now notice I have tests for 2, 3, 4, 5, 6. I don't have one for 7. I don't have one for 8. Okay, but if we want to know if a number is divisible by 7 or 8, we can just say, well, take 3,420 divided by 7. There's no really test for those ones. Okay, there is a test for 8, but it's a little more complicated. And then other than that, check numbers like 11 and stuff like that. So this will help. These will help us to tell if a number is prime or not, and it'll also help us when we need to do the next thing that we're going to do. So let's move to the next slide.